values are negative. But like on this guy, it's negative 23.69 and the flow arrow is to the right. That doesn't mean the flow is actually moving to the left. The flow is moving in the direction the arrow is showing you. Okay, the value sometimes is positive and sometimes is negative, and that's only just dependent on what the start node and end node are. So in this case, because the start node is defined as 8, which is here, and the end node is defined as 7, which is here, but the flow is moving this direction, it has a negative there. But so the value, that's just computationally, it needs to do that. But the flow arrow is correct in terms of showing you which direction it's going. So that's one way of looking at flows and pressures. I can also go up to the report menu option, and I can go down to either graph or table. Let's go to table first. What type do I want? I want a table of all the network nodes, and I can define what I want to see about them in the columns here. I can hit OK, and it'll show me all the junctions and what all their demands are, and what all the head is, and what all the pressure is. I can do the same thing for the pipes. Hit network links and hit OK. And again, it makes a table. Now, if you ever want to get this data out of here and into Excel, for whatever reason, you cannot just highlight the data and hit like copy. There's no way to do that. But I can go up to edit. And if I highlight the whole thing by hitting this upper left square, I can go edit and then copy to, and then I can copy it to the clipboard or to a file. And if I copy it to the clipboard, then I can go to Excel and copy it in. What? Clipboard is an imaginary, well, it's not imaginary, it's a operating system construct that puts anything you copy on the clipboard. So you can't see it, but then you go to Excel and you press paste and it'll paste it from the clipboard. So copy to clipboard just means so that you can paste somewhere else. Yeah. Okay. I can also view graphs. Graphs are not super helpful in these steady state simulations. They're much more helpful when you have a time series and you're looking at how things are changing over time. There may be some things you find useful in here. I'm not going to spend much time on it now unless I can think of a reason like next week to show you some different things. But let's get out of that. So now that I've run a simulation, I've looked at some of the results. I can also, by the way, I mentioned you can change some of these contours. So if I would like to further refine, say, the flow so it's not all blue and green, I can right click on that legend and I can change the flow boundaries so that, say, I could say make this 20, this 30, this 40, and it's 50. And that'll change a little bit so I can see these pipes are higher flow just at a glance. So now I'm going to add my fire flow node. You can see this system works pretty well. Everything's great. My fire flow node, according to this table, is node 12, which is the lower right node in the whole figure. Yours is probably not going to be called node 12, but it's this guy in the lower right. And that we're going to change its base demand to be 2,500 gallons per minute. That's the only change we're going to make. And then we're going to run the analysis again. Warning messages were generated. See status report for details. Warning, negative pressures. All right. So here we are. You can see the flows have gone up considerably. And I'm looking at the pressures. All my pressures have dropped. And particularly you can see as these are my pressures located at the nodes. As I get closer and closer, as the flow's coming from the tank, coming from the pump, as I get closer and closer to where the fire is, I'm losing head as I go. So here I'm at 38, now I'm at 26, my pressure. I can also go down this way, 43, 34. And then I've got this really long pipe here, 6-inch, really long pipe here. Both of these, all the water has only these two paths to go. Up here, it can split a bunch of different ways and get around. But once you get down here, it's got to go 400 feet through this 6-inch pipe, or actually technically, was it 400 and then another 2,000 through that pipe to get there. And by the time it does, the head loss is so significant that the pressure is negative 8 psi, and it's warning me about that. What's that? In reality or in the model? In reality, it means that you would turn on the tap or they open the fire hydrant and it would be, nothing would come out, and in fact, it would want to suck air into the system. If a tap was open somewhere else in the system, it would suck air in and bubbles would start going through the system. So that's bad because you want to open the fire hydrant and have water spray out. So there's minimum pressures that have to be met there at the hydrant under fire flow conditions. But you also, under fire flow conditions here, you need to meet all your pressure requirements through the rest of the system. Now, it's okay, generally speaking, and it varies by jurisdiction, there's a design, you want to be between 30 and 70 psi in the system under most conditions. But a lot of systems will allow the system to temporarily be down to, say, 20 psi if there's a fire somewhere. So while the fire's going on, we're at 20, and that's okay. So our system met spec under the normal condition. It was 57 psi. That's good. Now we've got a fire, and we're not good. So if you go to your back to the title page here for Lab 4, you can see you have two tasks for this lab. The first one says, for the network developed during lab time, develop a solution to provide at least 20 psi to every node with a fire at node 12 and the worst pipe out of service. So, what does that mean? Well, all of my pipes are open right now, but what if a pipe was out for service and then there was a fire? I still want to be able to fight the fire because they're working on the pipe, they can't just get it in immediately. So what do you think, just by looking at this, what would be your guess of what the worst pipe to have be out of service would be if the fire is here? What's that? We've got some different boats. We think, it sounds like some of them are 15, 14, 13, 22. So for the fire here, yes, there are several kind of key links. We know it can go through multiple ways here. This would be one key link. These would be others. If I ignore this one for the time being and I just look at these, I can see that there's a lot of head loss going through this way because it's such a long distance. There's not as much coming through here. And in fact, I can't see actual head loss on my link view, but I can see what they call unit head loss.